So this is your initial power factor. This is your initial power factor and this is your final power factor. From here we have calculated the capacitance, or the amount of capacitance required to improve from this power factor to this. Okay, now you can calculate. Why we are calculating these all things? We want the ratings of capacitance ratings. Okay, capacitance rating. So how much capacitance we must use so that we can improve our power factor. So overall, if you have calculated this, so this is the capacitance, this is the capacitive power, and this is a three-phase capacitive power. Okay, now here if you see, this capacitance is connected in delta. Okay, so delta means same voltage, whether it is line voltage and phase voltage, both are same. So voltage will be same. Okay, now voltage will be same. What can you tell about your, and if there is a capacitor, xc is the capacitance. Okay, so for a per phase capacitance, you can say v phase square upon xc. Okay, and xc will be in per phase. So you can use your formula, P is equal to V square upon V square by R. Okay, so this, from this formula I replaced R by XC. So this is your power, this is your Q for single phase. Okay, now if you multiply with your three phase, if you want three phase power, you will get Q three phase. Okay, so if you multiply just by 3, you will get three phase power, and this three phase power is equivalent to your Q capacitance. Okay, now this is how you can calculate your whole power factor, and this phase voltage will be given. From here you have to calculate xc, and xc is your 1 upon 2 pi fc. Okay, so from there, if you calculate xc, you will put it here, you will get the value of capacitance. Okay, rating of capacitance. So we'll do one numerical. And then we'll see how we can change our how we can practice something. Okay, so let's start. So you can write down, or better I'll give it in a written format. Okay, but if you I'll read for you. It's a question on your gate question only, because generally this is the most this is the best concept they are using, they are asking in your gate. One of the favorite question they are asking in gate. Okay, so this is what you need to remember, this formula QS. Okay, so here the question is a three-phase induction motor rated at 400 volt 50 hertz. This is 400 volt 50 hertz. Okay, 50 hertz, coupled to a pump, and this is coupled to a pumping ground. There is a pump connected here. Okay, is running at a lower power factor of 0.6 lagging. So it is running at 0.6 lagging. The input is 4.5 kVA. So S, it is given as 4.5 kVA. Okay, it is proposed to improve the power factor to 0.8 lagging. Okay, so here it is proposed to improve this power factor to 0.8 lagging. Okay, now how we can approach by using a connecting a delta connected capacitor bank. Okay, find the value of the capacitance per phase. Find the value of the capacitance per phase. Your options are: option A 10.1 microfarad, option B 20.1 microfarad, option C 15.1 microfarad, and option D 21.1 microfarad. Okay, so overall this is my reactive power, and these are the things. I have connected a delta connected, and we need to find out the capacitance C, capacitance rating of it. So first we need to find out how much is your P. So how much power is taken by your induction motor. Okay, so first we will find out the P. So as you know that P is your cos phi. If you check it, so cos phi is P by S. Okay, so S is given phi. So what is your phi is concerned, because you have two angles 0.6, 0.8. So initially your motor, which when it is manufactured from the industry, this capacitor bank is not involved. So once you attach the capacitor bank, then only your power factor goes to 0.8. Initially it is operating it on 0.6. So you need to know this is the rated condition. Okay, so what will be, you need to take the rated condition. So you need to find out the power S in terms of this only. Okay, so P you can say S cos phi, and cos phi means cos 1, that is your initially given. So that is 4.5 kVA into, that is 0.6. So you will get somewhere 2.7 kilowatt. Okay, so this is your P, 2.7 kilowatt. Now you need to find out how much capacitor rating you have to put. For that you have to find out the angle. You have to, so we have a formula, that is capacitor is P into tan phi 1 minus tan phi 2. So you need to find out phi 1 and phi 2. So what you have to do, you have to take P, we have already calculated P. Tan phi 2, tan is cos inverse 0.6 minus tan of cos inverse 0.8. Okay, so if you, and here P is 2.7 kilowatt. So if you put the value here, everything, and then calculate it, so you will get, put the value 2.7 here, tan everything you put it, you will get 1.575 kVAR. Okay, so this is your reactive power, and this is your three-phase reactive power. Okay, this is your three-phase reactive power, and as our question have said, it is we need to find out the capacitor rating in your per phase value. So we have to find out the what is your per phase. So Q, capacitance per phase. So per phase means 1.575 upon 3. So you will get 0.525 kVAR. Okay, so this is the capacitor rating your in your per phase rating. Okay, now similarly, if you find out, if you put the, I need to find out the ratings of the capacitance. So what will happen, I have already told you that 0.525. This is the kVr rating, and here V square by XC. Okay, so V square is what? V square is 400 square. Okay, so that is your 400 square upon XC. Okay, so you will get XC is equal to 400 square upon 0.525, and you should keep in mind that this is in kVA, kilo kVAR, so multiply it with 10 to the power 3. Okay, then what will happen? Just put 2 pi f into C, that is equal to this much value. So if you find out the C value, C is equal to 400 upon 0.525 into 10 raised to the power 3 into 2 pi f. Sorry, so this is your 1 upon 2 pi fc. I made a mistake here. So this xc is nothing but 1 upon 2 pi fc. Okay, 1 upon 2 pi fc, and that is equal to 400 upon 0.525 into 10 raised to the power 3. So for capacitance calculation, just have to do the reverse order: 0.525 into 10 raised to the power 3 upon 2 pi f is 50 upon 400 square. Okay, so calculate it and you will get answer C is equal to 10.1 microfarad. So this is the option. So this is how you can calculate here. So I hope it's clear now. So in your exam, this will be one of the numerical. This type of numerical will be there in your exam, and and your power factor calculation is, I think, complete. I'll be uploading your unit 4. There will be one, as it is more related to your laws of electricity, so I will be giving one IPC code. Okay, there is a code for electricity, how can use in generators, and how at what generation point you should generate, at what consumers point you should consume. So I'll be giving some important laws that are included in India, and there is an IEEE standards also, so I will be giving you that, and then that's our whole completion of the syllabus. Okay, so if you have any problem, you can ask me. Okay, thank you.